Hi everyone, thanks for joining our webinar today. Minitab Statistical Software, exploring data relationship and patterns with regression and multivariate adaptive regression spline or MAS. I'm Nom Salawati. I'm the technical support specialist at Bizit Systems. Bizit Systems are independent representative Minitab for Malaysia, Singapore, and Batam, Indonesia. So here are a few housekeeping notes before we begin. We have a Q&A session after the presentation. So please submit any question you have and we will try do our best to answer them. Or if have a time, if no, I will answer afterwards by the email. So we recommend viewing this webinar on your laptop or PC for the best result. So please fill out our survey before you exit the tab. This survey will help us to improve the quality of our upcoming webinar. We record this webinar and upload to our website www.bizit.com and our YouTube channel, Minitab Malaysia and Singapore. So there's no problem if you miss anything or want to review afterwards. Okay, so Minitab was developed in 1972. So Minitab in market for more than 50 years for this year. Okay, so we have others product. We have a Minitab Connect for the data transformation and the dashboard. We also have our flagship product for today exploration. We have a Minitab Statistical software, and then we have a software predictive modeler. So for the machine learning and predictive analytics, some of the algorithm inside the SPN now available in Minitab Statistical software. For example, today we explore for the MAS, one of the algorithm from the SPM now is available in the predictive analytic modules. And then we have a Minitab model app ops, for help business analysts and engineers successfully implement their own machine learning and predictive models. And then of course we have others like Minitab workspace for visualization tools like template like VSM, value stream mapping, FMEA, and so on. And then we have, we call it, that one is the Minitab Engage. It's something like for project management, and then plus with the dashboard. Okay, and then we have the online training. We call it, that one is Education Hub. In the Education Hub, actually, they have a few modules like statistical inferences, regression, design of experiments, statistical quality control, and so on. And then we have the real-time SPC. It will make for the quality analysis and improvement easy in one convenient and comprehensive solution. And then with the real-time SPC, we help you to monitor and alert in the real time, allow for immediate action when quality varies or saving both time and money. And then today we focus on the Minitab Statistical software with specific tools is a regression and the MARS. Okay. So here some of the tools are available in Minitab Statistical software. For example, for quality, we have a measurement system analysis, control chart, capability, accepted sampling, and tolerance. So all these not include for the accepted sampling. I think I will cover already in our webinar in this year. Okay, so if let's say you missed this topic, so I think you can go for to our YouTube channel to see the measurement system analysis, control chart, and capability analysis. And then we have the other tools like reliability engineering itself, and then we have the product development. Okay, sorry, product with development, like you want to use the DOE. Okay, so we have a screen that design, we have full factor design, mixture design, we have RSM, and then we also have the business analytic. we have the correlation. For today, I will touch on it. And then we have the statistical modeling. So one of the here is something like regression. Okay, we have the Mars, and then we have also for the process validation. Okay, so for those want to interest on this part, we have all of those, but not in the sequence like this. Okay, you need to find the start. Okay, in the start menu, and then you will find all these tools are available in Minitab Statistical software. Okay. And then we have complete tools for analysis. So our customer coming from various sectors include the manufacturing, academician, services, and so on. And all the type of company may be fit to use this if the purpose to use the statistical analysis to be a data-driven company. So for our agenda today is about the correlation, your relationship, your pattern inside there after you identify your pattern, your relationship. So you go for the next stages, want to do the something like modeling or specific way, we call it the multiple regression. Okay, so I think we as a decision maker, we can use the regression equation to predict the outcome. So maybe it can determine which input can predict a response and which ones are the most impactful to your response. So maybe strong the models can even be used to calculate expected value and forecast the impact of the future changes. So hopefully in 1 hour we can cover all these things. Okay. Okay, so when we start analyze the data, one of the things we look is whether a certain pair of the variables are correlated. So correlation can tell if two variables, is it have a linear relationship and the strength of the relationship. So then we use the regression line, okay, to model the relationship between the response and various predictor. So once whether is the best between the regression or the mask, maybe we selected one of these and then we make the prediction. Okay, so one of the thing before we go further, we look on the correlation. So in correlation, we can do two things. You can get from the correlation. The first is your strength, and then the direction of relationship between the two continuous variables. Continuous means that it's a measurement. It's a numeric data, whether it's X or Y, must be a continuous data in order to calculate the correlation. So in the correlation, we call the correlation coefficient or R. It will the value of the R between the -1 and to the +1. So if let's say your R, it will be positive correlation, mean to say that the both variables tend to increase or decrease together. So which is your R, it will be a positive value. If let's say your R, it will be have negative value, mean to say that the others, one variables increase and the others tend to decrease. So it will be have the stronger relationship, it will be -1. So the R coefficient here will be -1 to 1. Okay, so no need to worry, Minitab will generate this value for you for the R. Okay, and then we have a two type method correlation in the Minitab. Currently, we have the Pearson product moment correlation, and then we have the Spearman rank order correlation. So I think most of us always use the Pearson product moment correlation. Okay, so if let's say you have a continuous data set, so you will go for the Pearson. But if let's say your data set is continuous, but let's say ordinal one, scale 1, scale 2, and so on. So you will go and calculate the correlation, but you need to use the Spearman rank order correlation. That one is available in Minitab statistical software. Okay, so we go for the next one. Okay, this one is the how to identify the relationship. So one of the good thing is you need to start with the scatter plot. Then in the scatter plot, actually we will use scatter plot to see the relationship between two variables. Okay, so for example, it will show the positive. If like you say your R is positive values, and you will see the scatter between the X and Y like this one. If let's say R is a negative side, so your scatter like this. And then for this case, when your R equal to 0, okay, so we have a two meaning, whether it's show the no relationship or show another thing is a non-linear relationship. So that's why regarding to identify your correlationship, so you must use a scatter plot in order to avoid this misleading for this thing. Okay, so is R equal to 0, maybe no relationship, or maybe non-linear relationship. Okay, so all these one are available in Minitab. So for this case, I have one case study here. Okay, so energy users commission encourage a manufacturing plant to keep monthly energy. Okay, users for the below. So this one, they begin by the considering the following predictor. It's a total unit produced, total equipment runtime, your employee hours, the mean outside the temperature, minimum outside temperature, and so on. So that one is they will consider the predictor impact into the energy usage. So they will want to know which one is the most impact into the energy usage for this case. Okay, so we try with this one. Open the Minitab project file. Okay, so for this plant energy here, okay, so for your information, maybe you go to right click, and then you will get for worksheet information. So in the worksheet information, actually they will show the columns name, okay, how many rows in the column, and the name of your variables. Okay, so that one is they will show on this case. Okay, so for this case, I think this one will be. Okay, so the one is still you just create. So everything in this one may just only update the result. So in this way, they give you some information, how many counts in this row, and then the name of your variables. Okay, so for this case, we want to our response, it will be energy here. So we want to produce the scatter plot between the mean temperature up to the average equipment age by the energy side. So which one is the most positive correlation? Which one is the most negative correlation? Which one is a no correlate with this energy? So what do we can get from this here? So we can start with the graph or go for the scatter plot. Okay, so we have, maybe we go for the simple one. Click OK, and then you must include your Y variables here. So our Y variable will be energy side. So maybe you want to go for the mean temperature. The next, maybe you want to go for the energy maximum temperature, and so on. And then you click OK. Now you will get the scatter plot. Okay, so now you will get the scatter plot, mean versus the energy, and then maximum versus the energy. So that one is if let's say you want to start with the visualization. But for information, if let's say you want to direct know about the R value, so you just go for the stat, go to basic statistic, choose the correlation. Okay, in this case, you just maybe all this information, select all this one. Maybe you go for the option here. You want to store or not store. And then you satisfy with this one. Just now I mentioned that we have a two type, whether it's Pearson or Spearman. So for this case, we go for the Pearson. And then you click OK. For the graph, maybe you want to get the metric plot. Okay, and you click OK. And maybe you want to the result. Maybe you want to have the method correlation and then pairwise correlation tables. So you just click OK and then you click OK. Now, Minitab provide this matrices plot is scatter plot also, but since we have a lot of variables, so they will make it in the matrices plot. And then they provide you the correlation here. So for this case, we have the correlation between the minimum temperature, but our interested in this energy versus mean temperature with the energy with the mean temperature, maximum temperature with the energy. So all this, you can see that all this one is the in positive correlate. So the total equipment RAM, it will be the highest value of the positive correlate between the energy here. Okay, so for this case, maybe you can go for the p-value to do the hypothesis testing, whether it's significant or not significant. So you will able to see the p-value here. Or I will go back to this one. Maybe you want a bigger one. Okay, just double click, go for the maximize it, and then you will see that the value of the R here, and then the confidence interval of value here. So it will be available on this case for the scatter plot or in the by using the correlation. Or we do go for the basic statistic, you can go for the correlation. Okay, so mean to say that now energy have the relationship between the mean temperature, but the highest value of the correlate between the energy versus the total equipment run. Maybe the first stages here, you can know that, okay, for this case, maybe most impact into the energy since they will have the highest correlation between them. Okay, but since we have another variables also, it will good. Okay, maybe the terms of row for this are squared below 0.5 is weakness. Okay, more than 0.5 up to 0.7, it will be moderate, and then maybe more than 0.7, it will be the high correlate. Okay, between this one. And then we have another, we call it that one is visualization. Once you facet with the multiple variables here. So we have other option. Go back to the graph, you will see the correlogram. Okay, so maybe for this case, you just put all this, select all this one, and then maybe you want to see on the display correction values here. And then maybe here you got just proceed with the default, and then you click OK. So now you will get the correlate program. So in correlogram, it will be the same as a correlation just now, but just give you more clear part or easy way to understand about the relationship since they provide you the color coding here. So based on this color code, you can see that the highest value is the total equipment versus to the energy. So that one is they will give you this information directly, and then they will provide you the R coefficient in here. Maybe they will use this part or you can use this part. So they have the option one. Okay, so suggested if let's say the smallest value of the data set, so you can go for the basic here. But if let's say you have a lot of data set, maybe start with the relationship, go for the correlogram. Okay, so this one is option for you to solve it, your problem. Okay, you can imagine like you already, your process now is a good, it's good mean that it's stable and capable. So you now want to more further to the modeling side. Okay, to do the prediction. Okay, so one of this start from here. Okay, so I go back to this one. Okay, so already put here this one. So after you know about, you already have the relation between them, so you try with the regression. Okay, regression is a classic tool for building the predictive models. Regression allows the user to model the relationship between a response and the various predictor. So we can determine which input and predict a response, which one is the most impactful. So the general equation for the regression, actually this is y equal to b0 plus b1 x1 plus b2 x2 and plus on so on, and plus with the absolute is a random error here. So your regression can be linear like this, maybe can be non-linear like quadratic or cubic. So if let's say you go back to the simple max, that one is we show the x squared, is it? So this one is maybe s cubed here. So it will back to your fundamental back for the regression side. So how they will get the b plus b not here b1, it will use the least square method to get this value. Okay. And then who can use the regression? So all of you can use the regression. It will, as long as you want to do the prediction, you want to study more about relationship and so on. So how in fact every predictor into your response. So wherever you coming from, manufacturing or maybe services, type of manufacturing or maybe automotive or so on. So everyone can use the regression. Okay, for example, you want to see on the cycle time, you want to see the longer cycle time or reduced cycle time. So what is the effect or factor into your cycle times? Maybe you want to see the strength, the yield. So maybe before you go for optimization, okay, you have a historical data, so you will use the regression before you go for the design of experiment and so on. Okay, so for example here, maybe you want to see how this processing temperature related to the mean hardness of the steel. Okay, what is the predicted mean hardness of the steel if the process at the particular temperature, which is something like, okay, at this temperature, what happened to your strength? What happened to your yield? So you want to that kind of this situation. What if situation? Maybe regression, one of the method to help you to get the answer. Okay. But in the regression type, we have a lot type of regression. Since we have a different problem you will face it. So that's why we have a lot type of regression. But the first thing, just you look on your response first, your measurement. It's a measurement, strength, length, or whatever. So we'll use the simple regression. Okay, simple regression means that only one response predictor effect into response. Only one X impact into your Y. For example, you just only one X, so you will go for the simple regression. But once you have a more than one X factor, so you will go for the multiple regression. Okay, but if let's say your model, your relationship is not linear relationship, okay, straight line, you cannot form the straight line, you will use the non-linear relationship. Or maybe you want to look the variability, so you will go the partial least square. But if let's say your Y is accept or reject, yes or no, so you will go for the binary, just only two outcome, okay, yes or no. But if let's say you have the ordinal, so let's say you have the rank of your response, okay, it's a lower, medium, high. So you will use the ordinal logistic regression. But if let's say your response is with nominal, okay, nominal means that like something like binary, okay, yes or no, okay, but have the doesn't have any meaning on that. Okay, it's maybe you can go more than 3 output here for the nominal. And maybe your data set is like event, so you will go for the Poisson regression. So all these type of the regression available in Minitab. But today I will focus on the multiple regression. Okay, the basic will be the same. Okay, the basic will be the same. Okay, and then just to inform you, regression, it will be statistical analysis side. So you must be fulfill this assumption. The first assumption, your residual. Residual means that your expected minus your actual part, you will get the residual. So your residual must be normally distribute. Okay, the normally distribute. Must be normally distribute. The second part, your variation must be a constant variance for the fitted values. So let's say you must have like this. Okay, you have the same plotting here, or maybe you have a pattern, something that one. It will increase, it will decrease. You need to have the same pattern to show the constant of the variance. And then the last part, you need to have your residual must be the random over the time, must be scatter around the zero or something, that randomly must be the randomly. So this one is must be for fit 3 of this one, must all this. Okay, not only, okay, for this case, my assumption just only proceed with this one. So we not consider that will be the best model. Okay, because we want to use this model to do the prediction. Prediction meaning to say that the process, it will not happen yet. Okay, not happen. Okay, to do the prediction. So that's why we need have the high accuracy and so on. So that why we check on this assumption. Okay, so I go back to that case study just now. I will show for you. We use the same case study here. Okay, for the plant energy, so it's our Y, our predictor, it will be the energy. The rest will be the predictor. It's our X or parameter or so on. It will can be a different name. Okay, so for this case, so you can go back to the start. Okay, you see regression. So you see the all type of a regression in here. So for this case, we go for the regression, fit regression models. Okay, so of course, our response is energy. Okay, so our continuous predictor, it will be here. Okay, maybe for a case we know we doesn't have for the categorical predictor. Okay, and then maybe you can go for the models, interaction and so on. Click OK. You go for the graph. Okay, what you want to see on the graph. Actually, the one is the assumption graphical. Just now we show for you. So maybe you can go one by one, or maybe you will go for the 4-in-1, or maybe you want to see the Pareto here and click OK, and then you click OK. Okay, so I will do, go to stat, go for the regression, you go for the regression. So you choose the fit regression models, you complete, okay, your dialog box with this information. Maybe you go for the models, maybe you go for the graph, and then you click OK, so you will get the regression site. So in this case, they will have the regression equation here. So this one is just now we show is a y equal to b0 plus b1x, b2x, and so on. So that one is the, we call it the regression equation. Okay, and then the most important here, we look on this okay, maybe r squared here. Okay, this one is r squared. Is almost 100, okay, 99%. So mean to say that this equation will be the good, okay, it will be the good model to do the prediction. But we have others interesting part from here. We also have the Pareto here. Okay, you see on the p-value here. Okay, they will provide the p-value. Regression is significant. Okay, we proceed with the each factor here. So it is that one only the total equipment round will be the most significant into this regression site. So maybe from here, you need to refit the model. Okay, remove the others not significant to get the best model. Okay, before you go for the prediction. And then the other thing you need to look on this normality side. Okay, for this case, I will try with this one. So all this information is the R. Okay, it will be, it's not so good. Okay, the more important here is not so good. Okay, not significant, only this total equipment run is significant. Maybe we go back to dialog box. Minitab will provide you on this step, what we call it. Minitab will help you choose which one is the best model for you. Okay, no need to run manually. So maybe you go back to the none. We have the stepwise, we have the forward selection, we have the backward selection. So for the forward, backward selection, I go back to this part. Okay, so we have these three can be automated. The alpha criteria for the value, it will be step forward, okay, forward selection or backward elimination, or we have a AIC, BIC, and then we have the R-squared value for predictive fit of the model if a validation. This one is available on this to the 3 common procedure. But today I focus on the stepwise and forward selection on this case. Okay, so we have the others information or others method to get the model selection on Minitab statistical software. Okay, so we go back to that. Okay, for this case, I try with the most frequent our customer use is stepwise here. It's the stepwise. So stepwise means that they include that value and then they remove back. Include that value, remove, and so on. So you will see on the display the table of model selection data. So Minitab provide on this information to see on this. So I try with this one, and then I click OK. Okay, and then I click OK. So now Minitab will fit model for you. So you can see that this regression more easy, okay, more simple rather than just now. Okay, and then you will see your R-squared also increase better. Okay, and then you can see in this just only this part of the mean maximum temperature, your total equipment run, your average equipment age, it will be most important into the regression. So that's why both of these 3 part of the the predictor, it will be appear on this regression equation. So for here, you can check your assumption is a normality, and then that one is show the constant, okay, the constant of variation, and then that one is plotting it and randomly plot on this one. So all this one is satisfy all this information. So maybe you will use this for prediction side. Okay, you will use this equation for prediction side. Okay, so maybe you go back to the stat, go back to regression, you see the regression. So now once you have the models, you fit the model, you get the model, you will see that one now available to do the next stages. Okay, so for this case, you want to do the predict. You want to do predict. Once you already have this, the best model on this case. Okay, so for this case, your energy here, okay, maybe you want to enter individual, or maybe you have your own value, so you can put on this value. So for today, I just focus for one single value only. Okay, I have the maximum temperature here, it's 77.65. Here it will be 1996.4. Okay, and here is 88.5. Okay, so all this, maybe you can go for the info. You want to do you want the confidence interval on this side. Okay, view the result, you want to this one, and then you click OK. Now Minitab use this equation to get the fit here. Fit here means that is the predictive value. Okay, prediction value based on this setting, include in this equation, so they will get your fit. And then decide that they provide you the confidence interval and the prediction interval on this case. So you will get on this value, between this value to this value. So that one is a refit model. First, you build the model. Okay, that one is you have a complicated, maybe you have the, okay, the term of row here, the best model, if let's say you have the least number of the predictor, it will be the best model. Okay, so maybe you can go for the refit model, okay, by the stepwise, and then after you satisfy with this question, so you will do the prediction. So now without do the experiment, so you will use this information, and then you will get the energy prediction for this case. So that's why you need look on this R-squared must be the highest value, because you want to rely after this with this only equation. Okay, so this part, maybe if for those are related with the DMIC project, so you will use for the measurement or for the analysis stages. one of the tools we always use the regression. Okay, so you have the simple data set coming, okay, and then you have your problem here, your output here, your your parameter here, and then you want to see on the prediction here. Okay, and then we go back to this one. Okay, whatever this. Okay, all right, then this one. Finish. Okay, so for those maybe before this you will have something like machine learning, or you have a lot of information on that one. Okay, we have also for this information now regression also available for validation part. Okay, so you have a lot of historical data coming, you want to do the validation. Why we need have the validation? Because if let's say before this, okay, before this we assume that, okay, when you model with fitted with the you have the model, and then you use that model to do the prediction, the model will be the good. Okay, but now before you go for that the idea, you must do the evaluation part, okay, within in your historical data also. So that's why they will have the validation. So validation part is come to, like say you divide your data into the training and the test data set. So training, you build the model, just now I will show, and then after 1/2 of that one, okay, you test the model. Okay, and then during do the dividing between the training and the test, they have a type of the divide, how you divide. Okay, so we call it the method of validation. Maybe we can leave one out of validation. Okay, you have the total 199 we are the training data set, and then one it will be the test data set. Okay, and then we have the option, we call it the K-fold cross validation. So you have 100 data set, you divide by 10 group. Okay, 10 group. So 9 group will be the training, build the model. Another group will be the testing model. And then you round back. Okay, another 9 will be the training data set. Another one it will be the test data set. You round up to how many group you divide the data set. And then you will come up with the new models. And then maybe you want to have the validation test set. Means to say that 30% it will be the test data set, another 70% it will be the training data set. So it will be the value will be different between all this one. Okay, but always come to us which one is the best. Okay, it will depends on your data set. Okay, it will be depends on data set. Just the guideline, if let's say less number of the data set, you will go for the left one out validation. But if let's say you have no moderate data set, you will go for the K-fold cross validation. If let's say you have more big data set, you will go for the validation with the test data set. Okay, it will depends on your data set. Okay, if let's say you show for me, so also I cannot decide that which one is the best. Okay, but that guideline only there's one based on the number of your data set. Okay, and then here how to get it this validation in Minitab. Okay, it was easy to find out. I'll go to the stat, go to regression. I choose the fit regression models, and then you can see here is validation. Okay, in order to choose which one is this one. Okay, for this case, maybe I go for the K-fold cross validation, or maybe I will choose the validation with the test data set. So for this case, actually in the regression side, whether you can go for the stepwise to use the method here, stepwise, the forward information based on the IC, BIC also available. Okay, and then you have the validation. And then of course you will ask which one is the best. Okay, so this answer it will depends on your data set also for this case. Okay, so it will depends on your data set also for this. Okay, so that one is the simple models without the interaction. Okay, I just proceed with the simple one. But once you have something like the biggest data set, something like complicated relationship between the predictor and then energy, and then you can see that you have the relationship between the predictor. I go back to the correlation here. Sorry, correlagram, easy to see. You can see that they have a correlate between the total equipment between the mean. Okay, they correlate with this multi-correlativity, we call it. If let's say you have that kind of the situation, it will impact into your model. Okay, so that's why Minitab come out with the new algorithm to take care on this part. We call it here is Multivariate Adaptive Regression Spline, or the MAS. Okay, so this MAS actually they were combination of the linear relationship just now. Okay, so this one you can see that one line here, second, third, fourth, and so on. Okay, so MAS is we call it the Multivariate Adaptive Regression Spline. And then it was introduced by the Jerome H. Friedman in 1991. Okay, the MAS modeling engine build the models by pieces together a series of straight line. Okay, it's straight line. And then with each on is they will use the own slope. Okay, and then of course, for the good news, MAS is the non-parametric regression. Okay, mean to say that once we see non-parametric regression, so you no need to check the assumption just now. No need to regression. Residual must be normal distribute. Your variance must be constant. You must be randomly. Residual must be randomly. No need to care about that because MAS we consider as a non-parametric regression. And then in the MAS automatically model, we can see that non-linearity. Okay, because they will piece with one straight line, one straight line, one straight line, one straight line. So that's why the equation will be like this. Okay, your regression equation like this. B naught, just now B naught. B1, BF1. BF mean to say that is the basis function. Okay, basis function 1, basis function 2, and so on. So generally, basis function can be our maximum 0 to f. F can be our x minus c here. Can be like this. Your basis function can be that this. But so c mean to say that is cannot. Okay, is the end of this linear value. End of this linear value. Okay, so you will see on this, let's say, just now I showed the correlation, positive correlation, negative correlation. So for this case also the same. We have the positive coefficient, we have the negative coefficient like this. Okay, and then they have positive coefficient like this one. So you can see the C minus X. Here is X minus C, and then so on. So actually the MAS like this. Okay, the MAS like this. First, they will fit like regression, but after that they add another line. Okay, find the predictor greatest improve in the fit, and then they add another line here. Okay, will be fit with this line, and then after that they will use the stepwise backward. Just now I will show on the regression side. Okay, so they provide all the line, and then after that they remove one. Okay, after that they add one back, they remove back, and then so on, and then they come out with the best value for this case. Okay, so that's why there will be non-linear relationship. Okay, so since they will have the basis function here. Okay, so if let's say in a regression side, linear relationship, we just assume one line. But now in the marks, actually they provide you this. They form one line, they form one line, they form another line, they form another line. So that's why they come out with this one. Okay, so no need to remember this equation. Okay, so how to get all information Minitab provide for you. So maybe you can want to know about how they will get it. Okay, so how the mass will works like this. Okay, also they will use the stepwise here. Okay, and then I will go that data set. Okay, I will call that data set. Okay, I have the solar energy here. Okay, I have the solar energy. The same case study, not the same case study, the same situation. Okay, where you have your energy, solar energy power, and then you want to know or do the prediction. Okay, and then before you do the prediction, you must have the model. Okay, let's say regression or let's say for the mass non-linear relationship between this energy. So we have the sun evaluation, sun direction, temperature, precip, cloud, all this one impact into the energy. And then we try with this one, okay, with this Mars. Mars is available in predictive analytic module only. This one is the additional fee for this. Okay, after this maybe you interested, and then you find in your Minitab basic the one is the predictive model. We have the cost additional for this predictive analytic module. So how to get it? Go for the predictive analytic module and go to the mass regression. So you go for this one. In the response, of course, it's our energy. In continuous predictor, all this not include the time, and then select all this. For the categorical, is the one difference. And then just click OK. Maybe go for the validation side. Okay, so they have this information. Click OK and then click OK. So now you will get the equation also. But regression equation, they mention the regression equation, but they will provide this information. The basic function one, okay? So this one is our equation for the Mars. So this one is the beta not. This one is beta 1, PF1. Okay, so this one is a coefficient for the basis function 1 here. Okay, so basis function 2 here. And then, of course, we look on this value, the R-squared value, or maybe you can look on this model summary. So based on the R-squared, it will be high value in more than 70%. So we consider it will be the best model. And then you can see that the total predictor here, it will be 9. The important predictor only 8. Okay, mean to say that must already remove one predictor here. And then the maximum number of basis 30, and then the optimal number of basis function is 20. There's only 20 basis function in this one. The maximum will be 30 basis function. And then the most important here, we can see on this part. Okay, this one is the relative variables important. You can see that, okay, in the Mars, actually the sun elevation will be the most important into the energy. So in the Mars algorithm, actually they provide you this information directly. But just now you go for the regression side, you need to go for the p-value, or maybe you can go for the Pareto chart here. Okay, you can go for the Pareto chart. Seems like relative, but in the Pareto chart, they not come out with the percentage, how effect into this one. But in the Mars, they already put the sun evaluation will be the most important predictor into the energy, followed by the sun direction, cloud cover, and so on. So maybe you just look on the 20% most important into the energy. So just only 3 of them will be most important factor into the energy. And then maybe you want to go more details for each factor. So we call it, that's one is we call it one predictor, or we call it PDP plot. It's a partial dependency plot. You will see that here is sun evaluation, and then here is the energy side. So you can see that, okay, the first line here, maybe the straight line. After that, there will be they will increase. After that is a remain, maybe increase, and after that they will be decrease like this. So you will get, okay, for this cloud cover, this one is the first, okay, they will increase energy. Okay, when your cloud increase, so your energy will increase. But at the same time, at this point, your energy will be decreased. Okay, seems go for this sun direction. It will be not the straight line. So for this value of the sun direction, the energy value will be like this, but will be decreased. They will increase back. and then they will be decreased back. It will likely pattern in here. It's cyclic pattern or something that one. So you can get information from this one. Also for this case, you will see increase, and then after that remaining the value of the energy. Mean to say that if let's say you increase the number of pre-site, also your energy will be 0. So you can get the value of the optimization between this direction and this direction. And then of course, after you satisfy with this model, okay, you satisfy with this model, with this equation, the how many basis function, so you can go to the prediction. Okay, to the prediction. You just click predict here. Okay, predict, and then of course here maybe you can go for the individual just now, or maybe you can go for the by the column here. Okay, so by the column here. Okay, so for this case we have that. Okay, just I now open the data set, the predict data set. Okay, I go back to the Mars. Okay, and then I do the prediction. So here is the sun evaluation. Here is the sun direction, your temperature, this one, okay, cloud server, humidity, okay, wind, pressure, and then wind differences. Okay, so all this you will get, and then you click OK. So you will get this fit value. Fit means that the prediction value, okay, we get on this worksheet. Just now in the regression side, you will get in the output, but in the mass or other algorithm in the module or predictive module, will you get the predict value in this worksheet. So individual value you will get. Okay, so we get on this case. So what we want to show that regression or Mars, your objective will be the same. You want to do the prediction. Once you have the relationship between them, between predictor and then the response, so you can proceed with the regression or the Mars. Okay, the one which one is which one is the best? It will depends on your data set. Okay, but just only information. If let's say you have a lot of data set like this one, okay, your solar energy, I go for the worksheet information, so you get more data set. Maybe you can go for the advanced algorithm. Okay, let's say Mars or others algorithm. For this case, I just show for the Mars algorithm. Okay, so Mars regression, is it we can do as long as you say that that one is the good algorithm. You will get the highest value of the R square here. Okay, maybe you will get the highest value on this R square. Okay, you can look on the R square here. Or maybe you don't want to look on the R square. Maybe you want to see on the RMSE, MSE, MED, and so on. So we provide on this thing. Okay. And on the Mars also we provide the select alternative model. So you not the one what let's say Minitab choose for you for the optimal model. You want see the less number of the basis function. Maybe you go for this side. Okay, you satisfied with this side. Okay, with the 6 basis function only, with the 4 number of predictor only. So it just display our result. So you will get this information. Just some simple information, and then you will get the summary. Maybe you can go for the relative variable important, and then you will see on this PDP plot. So the same thing, just you refit the model, refit the models, and then we get the best model before you go for the prediction. Okay, so hopefully we already cover all this. Okay, for the prediction, the Mars, okay, the dependency plot. Okay, for the Mars, actually they will come up with the standardized value. Okay, they will standardize value on this. So that's why they will start with the 0. Okay, that is the standardized number. It's transformation. Okay, and then do the prediction also already. Okay, so now your turn. Is it you have question on this case? Okay, but don't worry if let's say your process now is not in control, your process now is not capable, as long as you have historical data, you're aim to do to study about the predictor itself, to study about the relationship, so you can go try with the regression or Mars. Okay, maybe you can go for the regression first before you go, let's say, for the Mars. Okay. Okay, so do you have any question? Is it a heavy topic for today? I think after you do something like a fishbone diagram, okay, you transform your method in term the data side. Okay, so I think you will get the predictor. Okay, the predictor and their response. So you try combine together, and then you will come out with the models. Okay. Okay, yes, I will send this material, but you need to drop your email in the chat box. Okay. Okay, we have a question here. Oh, okay, this one is we consider is the webinar. It's not the training site, so we not provide the certificate attendance. Okay, that one is a free. If let's say you have a time, and then you can join us to see the others information for those help you maybe after this, okay, after this webinar. Okay, my email address in this here, okay, sorry, it's a smaller one. It's a noor.sulawati@bizit.com. Okay. Okay, so anything about the technical part, you can email me directly. It's not for today's topic, maybe the other topic related with the Minitab statistical software, Minitab product, you can email me. Okay. And then good news for you. Okay, good news for you. We provide the we want you learn more about the predictive analytics with us. Okay, so we provide the free workshop. Okay, after this, maybe you want to try by your own, but no data set or something like one, or maybe you have a free time to join what is the predictive analytics actually, so you can join us into this workshop. Okay, so the date is 14 September is the Thursday. It will be half day event, and then that will be the hands-on session. Okay, so we provide the information, the data set, and then you try with us. Okay, is it, and then at the time maybe you have a question, and then you can rise on that thing. Okay, so if let's say you're interested, you can scan to this barcode, or I will share the information. Okay, I will share the link into the chat bot. Okay, after this, maybe you can is you can go, sorry, right? Okay, I try this. Okay, if you have a time, I think it's a good for you to try it. Okay, this one. Okay, so you can join us for this workshop. Okay, to try by yourself. Okay, to try it, the predictive analytics stuff. Okay, you maybe after this you will get the link. Okay, after you sign up, and then you can provide to try with the others algorithm like tree diagram and the mask just now I show for you. Okay, and then if let's say no question, okay, I think I ended this webinar. Okay, so thank you for your time and attention. And then to learn more about the Minitab, please contact us by visit our website www.bizit.com or www.minitab.com, or email to us to sales@bizit.com or minitab@bizit.com. So to get some tips and tricks on our Minitab product, Okay, please follow us through media social like Facebook and link at Minitab Malaysia and Singapore to access back our previous webinar. So please subscribe to our YouTube channel, Minitab in Malaysia. Hopefully we can add more subscriber for this YouTube channel. And I really appreciate if you fill out our survey in order to enhance our webinar session. So maybe see you next time with the different topic, and happy learning.